Hi everyone, welcome again to the Data Science Bytes channel. Data Science Explained Simple. On a previous video, we talked about using the memory profiler module to profile the memory usage for a Python script. Now this time we want to do the same, but the difference here is that the program is actually using some sort of multiprocessing. When you use multiprocessing, it gets a little bit more challenging when it comes to how the system will be able to track memory usage. So let's try to do that today. I have some boilerplate code here in front of me. I imported NumPy and of course the multiprocessing module and the memory profiler. And I have main here, so add profile, we're going to profile this, and we can use the context manager for multiprocessing, so we can do mp.pool, and let's just use two children at the same time, and this maybe add as pool. With this context manager, we'll take pool and we'll map a particular function that we're going to call. Let's call it get underscore ram for now. That function is going to map two values, 515 and 124. So these values are actually how many megabytes we want that function to return to us. So let's call it get ram as we called it over there, and we can call the variable pass here mb. So of course this is def, and all it does, it actually just returns to us an mpy.random.rand, and in that one we will get the mb that is multiplied by, remember, the 125,000 that we used on the previous video, and this is what we are going to get from this particular function. And of course we can also profile this one, profile this particular function. So now what we have here is we have two processes that are going to be spawned at the same time. One is calling for an array with about 500 megabytes and the other one is about 1000 megabytes. So if we save this file and we try to run it like last time using mprof, so mprof run a memory prof2. If we do that, we're going to get an error, and that error will mention something about pickling. So it fails to pickle the function that we have here, the getRam function. So what we're going to do then, what we can do here, and the reason for this error is that once the memory profiler actually discovers that there are some multiprocesses going on, it fails to serialize those. So we need to tell the memory profiler that we have multiprocesses in the program here, so it can be able to serialize those functions properly. And to do that, all we're going to change here is just to add a flag minus capital M, and this stands for multiprocessing. And if you run it again, boom, this is what we get. We get memory profiling for our program. And as you can see here, we have around 1 gigabyte on the second occurrence here, and on the first occurrence we have about 500 megabytes. So the first process actually consumed about 500 megabytes, and the second one consumed about 1 gigabyte, and this is really what we expect to see. Now, like what we did last time, we'll do mprof plot. We can actually add like a title, and we can call it maybe mp, just for mprof. And if you run this, we are going to get a very different plot compared to what we have seen on the previous video. Here we have two children. The blue one is one child and the red one is the second child process. And it is very clear that the memory consumption is different among the two. So the first one went up to 1 gigabyte and the second one went up to like 2 gigabytes, and there is a peak like almost 3 gigabytes. And you might be asking yourself as to why really we see this. Now, one of the things that we need to understand about multiprocessors here is that it's not only about the memory that is actually required for the operation, but also there is a memory required to return the values to the main program. And this holds true for both of them. And in addition to that, you see some peak here and there, and this peak is just due to the way Python actually is doing garbage collection. But we need to maybe pay attention to the black process here, which is the parent process, and see really what happens. So once the blue process, which is child 319214, actually finished, it starts at this point after 1 second to dump the result back to the main program. Once that is done here at this vertical red line, then the first child actually kind of zeroed the memory used, and then at that time the second child was still building that massive array. Once that is done, it started also to dump that returned value to the main process here, and once that is done at about 3.4 seconds, the second child actually got rid of all the memory that it has consumed. And again, the last peak that we see here is due to garbage collection. So what we saw on the command line is a little bit different. What we saw on the results here is what we expected to see, but what we saw on the plot is not the same. So we need to be aware of that. We need to know that what we see here on this memory profiling result on the table here is not exactly what happens under the hood. Thank you for watching this short video. I hope you liked it. Stay tuned for the next one.